Hi everyone, we're solving this physics paper today. This is 9702, paper 13. 9702, paper 13 from the May June 2024 series. The time is 1 hour 15 minutes. It's paper 1, multiple choice physics. I'll be rolling out chemistry followed by biology next, so look forward to that. Yeah, then I'll be rolling out more math papers, mechanics, statistics, followed by chemistry, physics, and bio paper 2. More paper 4 and paper 5 throughout January and February. And I'll be launching the October-November 2024 papers as soon as they're out after January 11th. By the way, great news for the channel. We are actually launching our first physical location this February. So if you're from Bangladesh, if you're a student from Sunnydale, Green Hills, Scholastica, Academia or Mastermind, or the other schools here, or even a private candidate, please feel free to join. I'm going to be launching 2 batches, one for mocks for all subjects. It's just priced at 80 USD or 9,500 BET. It's a one-time payment for 3 months of exams and solution classes provided. You can attend physically or online. It's hybrid basically. There will be 10 to 12 mocks at least for each set. And also I'll be launching a crash course or a revision batch where we solve papers as well as compress the syllabus in a very, very short course, so that, like if you haven't studied properly throughout the year, the 3 months should be enough to at least grab a B or an A if you attend regularly. It's a monthly subscription of like 6,000 BET for A2 classes and 5,000 BET for AS classes. I'm launching batches for every subject. So if you're an international student, please feel free to join. I'll have separate batches for you guys. And if you're from Bangladesh, please feel free to join as well. I actually studied at Sunnydale myself. I graduated back in 2018. Now I'm done with med school. I'm done with my undergrad. Let's see what the future holds for me. But yeah, I want to focus on this a bit more since I have a free time, since I have some free time on my hands. That's that. And yeah, I actually got, a few awards back in the day. In 2017, I got best across 4 subjects, and in 2018, I actually got best across 3 subjects in A2, as well as the country highest mark in biology and mathematics. So yeah, I teach everything actually, these 4 subjects, math and science. So if you're interested, please feel free to join. Let's start without delaying any further. And if you like the content, remember to subscribe to your channel, like the video. It helps a lot with the algorithm, right? Okay, so let's take a look at the threshold before we begin. So this is component 1.3 actually, component 1.3. So for component 1.3, out of 40, A was at 31, B 28. So similar difficulty, if we compare to the other papers. So out of 40, A was at 31. A was at 31, B was at 28, C was at 24, D was at 21, and yeah, it was at 18. So as you can see, there's like a gap of 3 to 4 marks. So A star should be around 34. If you want A star, you have to get 34 in this paper. So you can solve along with me or just give the paper and match after you're done. That's totally up to you guys, okay? So let's begin with question 1. What is equal to 0.000005 joules, okay? So that's 1, 2, 3, 4, 5, 6. Right, 6. So 5 into 10 to the power minus 6 joules, which is basically 5 microjoules, right? Okay, so that's it. That's 5 microjoules. That's C. The measurement of a physical quantity may be subject to random errors and to systematic errors. Which statement is correct? A systematic error cannot be reduced by adjusting the apparatus. This is completely wrong because they are removed by adjusting the apparatus. A systematic error results in a different reading each time the measurement is taken. Wrong. It actually results in the same error each time the measurement is taken. Random errors are always caused by the person taking the measurement. No, not always. There are instances where it can be due to other factors, the apparatus or the instrument. Random errors can be reduced by taking average. This is 100% true. This is true. Okay, so 2D is correct. Next we have question 3. The Young modulus of the material for wire is to be found. The Young modulus is given by the equation shown. Okay, E Young modulus is equal to 4FL by pi d square x. The wire is extended by a known force and the following measurements are made. Which measurement has the largest effect on the uncertainty? And the value of the calculated Young modulus. So let's go for percentage uncertainty, shall we? So this one, it is 0.002 divided by 2.043. Okay, 0.002 divided by 2.043 into 100%. That's really low, 0.098%. Okay, next this 0.02 divided by 0.54 into 100%. But there's a square here, so it's going to be 2 times this. 0.02 by 0.54, that's 3.7%. 0.01 divided by 19.6. I think B should be the answer logically. This is just 0.05%, and 0.2 by 5.2 into 100%, that's 3.8. Oh, actually this is 0.2 by 5.2. It's actually 3.85%. So look at this. So let me do this again. 0.2 divided by 5.2 into 100%. That's 3.85%. And for the second one, 0.02 divided by 0.54 into 100%. 0.02 divided by 0.54 into 2 into 100%. Sorry, I forgot to multiply the 2 here. I told you guys, but forgot to multiply it. So as a result, the value is 7.4%. Okay. So yeah, B should be the answer. Two physical quantities combined together as a product can produce a scalar quantity or a vector quantity. Which product of two quantities produces a scalar quantity? Okay. So MA, that's F, that's a vector quantity. Force into displacement in the direction of the force. That is the work done, and we know that work done is in fact a scalar quantity. Okay. 5. The diagram shows a velocity time graph for an object moving in a straight line. What is the displacement during the last 2 seconds of motion? Trapezium. Okay. We know that the area under a velocity time graph is the distance moved to displacement. So trapezium, 6 plus 12, half into a plus b into height. What is the height? 2 seconds. Easy. 18 into 2 into 0.5, which is 18 meters. We are going to go for 18 meters, which is 5c. A block is moving along a horizontal frictionless surface, no resistive force, a constant force F, and there's a resistive force of 5 Newton acts on the blocks as it is moving in the direction of the force as shown. The graph shows the variation with time of the momentum of the block. What is the magnitude of force F? So we know that according to Newton's second law, force is the rate of change of momentum. Okay. So what is the change in momentum? 1.2 divided by 0.4. Okay. So is that it honestly? So there's an issue here. This F that we get according to Newton's second law, this is actually the resultant force. Okay, so yeah, this is fine. We got the resultant force as 3 newtons. We got the resultant force as 3 newtons. And here's the thing, this value is actually a negative gradient. That means the resultant force is actually minus 3 newtons. Okay, this is the resultant force because the gradient is negative. So according to second law, Newton's second law, The resultant force is proportional to the rate of change of momentum, and it's negative since the gradient is negative. Now we are going to find out F. How? F minus 5 Newton is equal to resultant force. So F minus 5 is equal to 3 minus 3, sorry. F minus 5 is equal to minus 3. So F is equal to minus 3 plus 5, which is plus 2. Okay? Tricky. 6 was tricky. 6 is A. Newton's third law describes two forces that are equal in magnitude and form a pair. Which description of the two forces in such a pair is not correct? Yeah, they do act in opposite directions. They act on different objects. They are the same type. They cause an object to be in equilibrium. No, this is false. The graph shows the variation with time of the speed of a raindrop falling vertical through air. Which statement is correct? Acceleration decreases to produce a steady speed. That is correct, because we know that the gradient of the speed time graph is acceleration, and over time the gradient decreases, becomes horizontal. Which statement about a perfectly elastic collision between two objects is correct? Both k and momentum are conserved. So total ke is conserved, so C and D are wrong, and the relative speed of approach is equal to the relative speed of separation only for elastic collisions. Yeah. 10. The diagram shows the view from above of a sprinkler system used to water a garden. Now the sprinkler consists of a tube of length 0.15 meters. The tube is pivoted in the middle and spins in a horizontal plane as it lets out jets of water from each end. The two water jets are in opposite directions to each other. Each water jet exerts a horizontal force of 3 newtons on the tube at right angles to the tube. Okay. What is the magnitude of the torque? Torque is net resultant moment. Okay. So we know that this is 3 Newton, this is 3 Newton. So torque is basically the distance between the two forces times 3 times the force itself. Okay. So that gives us a value of 0.45. So take any one of the forces and multiply the perpendicular distance between them. That is torque for a couple. An object is held in equilibrium by 3 forces. The forces all act in the same plane. The diagram shows 2 of the forces. What is the third force? Okay. Okay. Now, how to do this? This is 90, so this should be 35. Okay. So what is the component down below? Let's see. The component down below is actually 17 cos 35. 17 cos 35. So 43 minus answer gives you, if you subtract them, basically, if you subtract them, you actually get 29.07. Okay, and what about the component on the left? Sorry, my bad guys, my bad. This one is actually 17 sine 35, and this one is 17 cos 35. My bad. So 43 minus 17 sine 35. That is 33.249, and that one is just 17 cos 35, which is 13.926. Okay. So the resultant force is actually upwards of 33.249, and that is to the left. So we can actually find out the resultant one, which is going to be something like this, essentially something like this, by using Pythagoras theorem. So 13.926 whole square plus 33.249 whole square, and root over answer gives us a value of 36.047. So we are looking for a force that counteracts this, and the value should be 36, and it should be towards this direction to counteract it. A force that counteracts this, and yeah, that is appropriate with B. Okay, then for 12, the total number of forces acting on an object is 2. The object is in equilibrium. So of course, for equilibrium, net moment must be 0 and net force must be 0. So okay, they must have equal magnitude, so 1 must be correct. They must have equal magnitude, okay. But yeah, this is wrong. They must act in same direction is wrong. They must act in opposite directions. That should be the correct one. The two forces must act through the same point. Yes, this is absolutely true, or else there would be moment, right? So B is correct. The diagram shows the arrangement of atoms in a particular crystal. Each atom is at the corner of a cube. The mass of each atom is this, and the density of the crystal is this. What is the shortest distance? Okay, so we know that density is equal to mass by volume. The volume is equal to mass by density. So mass 3.5 into 10 power minus 25 divided by density 9.2 times 10 to the power 3. Let's do this. Okay, we're getting a value of 3.8 times 10 to the power minus 29. So this is the volume. Okay, this is the volume. So the general idea is this is the volume of each atom essentially. Now we are going to find out the spacing. The formula for spacing is cubic root of the volume. It's an estimation. It's basically an estimation. We just found out the volume of one of these atoms. So if you cubic root this is in meter cube. You're going to get the answer in meters. And that is an estimate of the spacing between each atom. So that's 3.36 into 10 to the power minus 10. 3.36 into 10 to the power minus 10. So the answer is C. This is a common question and it repeats. This is the general idea of finding out the spacing of each atom. 4 measuring cylinders are filled with the same liquid to the height shown. At which position is the pressure the greatest? So pressure is actually equal to H rho g for a fluid. So the more the depth, the higher. So here the depth is 0. Here look, the depth is 20. So that's 20 rho g, same liquid. And here it's still at the top, so no pressure. Here it's just 10 rho g. So the highest should be at B because there's 20 centimeters of fluid above. In many filament lamps, as much as 92 joules of energy is emitted as thermal energy for every 8 joules of energy emitted as light. What is the efficiency of a filament lamp as the percentage of the electrical energy converted to light energy? Okay. So for filament lamps, what is the goal? We want light. Okay. So 8 is the useful energy, and what is the total? This is the useful energy output, and what's the total output, like wasted energy as well as the useful energy? It's 8 plus 92. So if you do this, 8 divided by 100 times 100, it's just 8%. Yeah, it's just 8%. Okay. What is the unit of power? Power is work done per unit time, so that's watts or joules per second. An object is in a uniform gravitational field. The graph shows how the change in GPE of the object varies with the vertical distance moved by the object from a fixed point. So as you can see that the GPE is actually increasing with distance. That's the general idea. So we know that this is mgh, okay, and this is the distance or the h. So clearly mass does not change, it's a constant. And the gradient is actually gh by h, so we can get rid of h. So what do we get? We get the value of g. So the gradient is actually g because m is a constant, or it's mg, weight or a force. So as you can see, the gradient is constant, so the force is constant. So we are looking for a graph where the force is constant, and the answer is C. Next 18. What is the speed of the block after falling this distance? Okay. It's released from rest, travels 7 meters down the slope and falls a vertical distance of 3. Frictional force parallel to the slope of 5 Newton. Okay. This is simple mechanics, right? What is this angle? Tan theta, sorry, sine theta. 3/7. So can we just write this, that basically this is theta as well. So mg sine theta minus resistive force of 5 is equal to ma. So 2 into 9.81 into 3/7 minus 5 is equal to 2 times a. 2 into 9.81 times 3/7 minus 5 divided by 2. This is your acceleration. Now we can find out the speed here. Doing this, v square is equal to u square plus 2s. V square is equal to 0 plus 2 into 1.704 into 7. So v is 4.88 according to my working. So yeah, 18 should be a, right? 2 wires, one made of brass and the other made of steel, are stretched in an experiment. Both wires obey Hooke's law. During this experiment, the Young modulus for brass is less than the Young modulus for steel. So we know that Young modulus is stress by strain. So brass is less than steel. So the gradient of this graph is Young modulus, and the one for steel should be higher. And both obey Hooke's law. Okay, so they should be straight lines, not curved. They should also obey Hooke's law, and steel should have a higher gradient than that of brass. So according to that logic, 19 is B, because steel has higher gradient and they are straight lines. A sample of material is stretched by tensile force to a point beyond its elastic limit. The tensile force is then reduced to 0. The force extension graph is shown. Which area represents the net work done on the sample? Okay, so as you can see, the answer should be x plus y. Why? Because initially when we stretched it, it had x plus y plus z, but then when it came back, it was completely deformed. This energy z was then returned back. It was given to other forms, but it is completely deformed right now. There has been plastic deformation. So if you subtract that, this is the network done on the sample, x plus y. This is a very common question, so get used to it. After plastic deformation, this happens. 21. A wire is fixed at one end and is extended by a force F1 acting on the other end. This causes the wire to have an elastic potential energy of 0.15. The force applied to the wire is now changed to force F2. This causes the wire to have a new elastic potential energy of 0.6. The wire obeys Hooke's law. So we know that F is equal to kx, or elastic potential energy is equal to half Fx. So this is a constant. This changed. Okay. Now the idea is the energy changed from 0.15 to 0.60, so it became 4 times. Okay, it became 4 times its original value. The force applied to the wire is now changed to F2. This causes the wire to have a new elastic potential energy of this. So look at the fx graph. It obeys Hooke's law. So initially, when we had, for example, f1, the extension was x, and the area under the graph was half f1x, which is 0.15. Now the wire extended to f2, and since it follows Hooke's law, if the force doubles, the extension will also double. So the new energy is now half into f2 into twice x, which is 0.60. So force has also doubled, extension has also doubled. So if you compare these two, f1 and f2, how to get this value? Clearly f2 has to be f1 times 2. In that way you can only get 0.60. So f1 is, so f2 is twice of f1. This is the relation. 21 is C. This was a tricky sum as well. Okay. Next, the diagram shows the representation of a wave on the screen of an oscilloscope. The Y gain is set at 3.5 millivolt. What is the amplitude? Okay. All right. The amplitude is just two boxes. So the amplitude will be 3.5 times 2 boxes, 2 centimeters. So that's 7 millivolts. Next, a transverse progressive wave on a string has wavelength this and amplitude of that. The speed of the wave is 48 centimeters per second. Where's the distance traveled by a point on the string in a time of 2 seconds? Okay. So this is the wave. Amplitude of 1.5. A wavelength of 12 cm. Speed is 48 centimeters per second. Okay. So we can go for v is equal to f lambda. 48 is equal to 12 times frequency. Frequency is 4 hertz or per second. So time period is actually 1 by 4 or 0.25 seconds. So in 2 seconds. So we know that it's a transverse wave, so it's going to move vertically up and down. So suppose it starts here. Okay. Suppose it starts here. So in 0.25 seconds, what's going to happen? We know that the frequency is 4 hertz, right? This is a bit complicated. Why? I'll tell you. It moves for a period of 2 seconds, and in one whole time period, what is the distance a point travels? Look at one whole time period. 1 quarter, half of a time period, another quarter, another quarter. In one whole time period, it will travel 1.5 plus 1.5 plus 1.5 plus 1.5, which is 3 plus 3. It travels 6 centimeters in one time period. And how many time periods have elapsed in 2 seconds? 2 divided by 0.25. How much is that? 2 divided by 0.25, which is 8 time periods. So if you multiply 6 with 8, you're going to get the answer of 48 centimeters. That should be the answer. Because in one time period, it moves a distance of 6 centimeter. And in 2 seconds, 8 time periods have elapsed. So it moves 48 centimeters in total. Next, for 24, it's Doppler effect. An ambulance siren emits sound with single frequency f. The ambulance travels towards, passes close to, and then travels away from the station observer. Observer, ambulance towards, passes by, and then goes away. Which statement describes the frequency of the sound detected by the observer as the ambulance passes the observer? So when it's coming towards, frequency increases. When it goes away, frequency decreases. When it travels away, basically. So the logic is, when it's just by the observer, the frequency will be equal to the frequency observed will be equal to frequency of source. So it should be equal at that moment. When it is just beside the observer, it will be equal. But since it's going to be moving away, it's going to be decreasing now. So it is equal at that moment, but just as it passes by, it will then decrease. So 24 is A. And yeah, that's it. An electromagnetic wave has a wavelength of 138 picometers. In which region does it lie? So Gx, UV, IMR. The rule is this is 10 to the power minus 7, minus 5, minus 3, minus 1. This is 10 to the power minus 8. This is like minus 10. This is minus 11, minus 12-ish. Okay. 138 picometers. What does that mean? 138 into 10 to the power minus 12. Use that in your calculator. It's 1.38 into 10 to the power minus 10. So this is minus 7. Radio is minus 1. This is minus 3. So they won't give you vague answers like gamma and X-ray at the same time. There's a clear answer here, which is the X-ray. Next, a student investigates polarization of microwaves. The microwaves from the transmitter are vertically polarized. A metal grill acts as a polarizing filter when placed between the microwave transmitter and receiver. The reading on the voltmeter is proportional to the intensity of the microwaves transmitted through the grill. So Malus law. When the transmission axis of the grill is vertical, the voltmeter reads 3.5. The grill is rotated through an angle theta. So we know that I is equal to I naught cos squared theta. The voltmeter reading is proportional to the intensity. So it's fine. So let's do this. So we can just input 3.5 and 2.2 over here. So 2.20 is equal to 3.50 cos squared theta, since they are proportional. So 2.2 divided by 3.5 root over answer cos inverse answer gives us an answer of theta is equal to 37.5 degree. So here 26 is A. Two waves superpose, a resultant pattern is formed. Which statement must be correct? So they must like for superposition, amplitudes do not need to be the same. They can have different amplitude, that's fine. They have to be coherent, or they have to be of the same type. Like a water wave cannot superpose with a light wave, for example. Okay, so they have to be of the same type. And longitudinal waves can also superpose, like sound. They travel in opposite directions. This is not a fixed fact. Like two waves can superpose like this, or even if they move in the same direction. A water wave passes through a gap in a harbor while it diffracts. The gap has a width of 8. The wave travels directly towards the gap. For which wavelength is the diffraction of the wave greatest? So we have good diffraction. Okay, we have good diffraction when the width of the gap is similar to the wavelength. So that's D. When they're same. Okay, and the smaller the gap, remember, the smaller the gap and bigger the wavelength, the better, more diffraction. But since the others are very small compared to this is the best option. Okay, the angle of diffraction is the best for this. 29, we have a diffraction grating. Total of 9 bright dots form. Okay, what does that mean? 1, 0 order. 1, 2, 3, 4. 1, 2, 3, 4. First order, second order, third order, fourth order. Okay. So the grating is at the center of the semicircle and the lines are vertical. The separation is D. So we know that D sine theta equals to n lambda. So we know that like the angle is 90 degree for the fourth order. So we can try doing that. D into sine 90 is equal to fourth order times 5.50 into 10 to the power minus 7. So we get a value of 2.2 times 10 to the power minus 6. 2.2 times 10 to the power minus 6. So yes, it actually matches with A for the fourth order. Close enough, basically. And the others don't make sense. Because look, if you use other values, for example, if you used 2.8, okay? If you use 2.8 into 10 to the power minus 6 into sine 90 divided by 5.5 into 10 to the power minus 7, you would get 5 orders. With this, you get 5 orders. And with the next one, suppose 4.4 into 10 to the power minus 6 into sine 90, which is 1, divided by 5.5 into 10 to the power minus 7, you actually get 8 orders. You get 8 orders with this. But with 2.25, what happens? Check. 2.25 into 10 to the power minus 6 into sine 90 divided by 5.5 into 10 to the power minus 7. The maximum number of orders you can get is 4.09. So not even 5 orders. So 4 orders on each side and 9 bright dots. Which quantity is given by the product of charge and electric potential difference? So we know that voltage is equal to work done per unit charge. So potential difference into charge is the work done or energy transferred. 30 is B. The current in a filament lamp is increased. Which statement on the lamp is correct? If you increase current in a filament lamp, resistance actually increases because the temperature increases. This is correct. Voltage increases, it's like this, right? This is the graph. Resistance increases. Filament lamp. A student builds the circuit shown. All the lamps are identical. Which lamp dissipates the most power? Okay. They are all identical. So clearly the idea is the one that gets the most current will dissipate the most. So clearly this, because why does this get the most current? Because it's in series with the battery, okay? So it will get the most current. The current in this one will be the highest, so it will dissipate the most power because everything else is identical, okay? 33. The resistance of a metal cube is measured by placing it between two parallel plates as shown. Cube has volume vanes made of a material with resistivity rho. The connections to the cube have negligible resistance. Which expression gives the electrical resistance of the metal cube between x and y? We know that R is equal to rho L by A. So it's rho times meter divided by meter square essentially, or rho into meter to the power minus 1. So we know that volume is basically cube, or it's basically rho by meter. I'm looking for this unit. So that's C, because look at this, rho divided by volume, which is meter cube, into 1 by 3. We actually get rho by meter in C. That is the only possible one. I just matched the units. Therefore, circuit needs to be completed by connecting two resistors between points X and Y. The resistors can be connected in series or parallel with each other. Which combination produces the least resistance? So not series, because it's going to be added up. Parallel, let's try this. 1 by 20 plus 1 by 40 reciprocal. That's 13.3. And for the second one, 1 by 40 plus 1 by 100 reciprocal. That's 28.6. So clearly A will give the least resistance. Diagram shows a circuit that includes a cell with internal resistance. The switch is initially open, which show describes the effects on current 1 and 2 on closing the switch. When we close the switch, what happens to the total resistance? Total resistance due to the parallel circuit will decrease. Total resistance decreases. So what happens to this current over here, this I1? This will actually increase. Why? Because total resistance has decreased. I'll give you an example. Check this out, guys. Suppose this was 5 ohms and this was 2 ohms and this was 7 volts. So initially we had I1 and I2 were the same. The current was 1 ampere. But when you close this, suppose this is 5 ohms as well. Now 1 by 5 plus 1 by 5 reciprocal, the net is 2.5 over here. So the total resistance is 2.5 plus 2, which is 4.5. 7 by 4.5. What happens? The new current is 1.56 amperes. So this current has increased. It went from 1 ampere to 1.56 amperes. So I1 increases, and I2 it's going to decrease because the current is going to be split at this point. It's going to be split in half maybe, or basically it's going to be lower than the initial one. Okay, so it's going to decrease because it splits at this junction now. 36. The diagram shows a circuit consisting of a cell and 3 resistors R1, R2, R3. The cell has the EMF 1.6, negligible internal resistance, current in the cell is 0.64, potential difference across R1 is 0.48. Let's find this out first. Let's find out the voltage of this. So 0.64, yeah? So if you subtract 0.64 minus 0.32, you're getting 0.32. So the current entering here is 0.32. This is a parallel circuit. Right, so this will get 1.60 and these two will also get 1.60. Sorry, I split it in half, my bad. So since we know that this guy gets 0.48, what will R2 get? 1.6 minus 0.48, which is 1.12. Great. And we also know the current. So R2 is equal to V by I, which is 1.12 by 0.32, which is 3.5. Awesome. Next, 37. The diagram shows a potentiometer circuit used to compare the EMF of two cells. So the role of a potentiometer is to compare EMFs. XY is a uniform resistance wire. The fixed resistor has resistance R. A sliding contact is moved along the wire XY. When the sliding contact is at point P, the galvanometer reads 0. What does that mean? The voltage of this component is equal to the EMF of this battery. The circuit is changed so that the galvanometer reads 0 when the sliding contact is at a new position to the left of P. Now, if you are at the left of P, it reads 0. What does that mean? Now, the voltage of this is equal to the EMF of the battery. How is that possible? A few ways, okay? One way is we can reduce E2. One way is we can reduce E2. Is that an option? E2 is reduced? No. Another way is we could increase E1. Then the resistor would get more EMF from E1. Is that an option? No. Either E1 increased or E2 decreased. Because if you increase E1, this wire gets more voltage. Okay. The smaller portion gets more voltage and balances this. Or if you decrease E2, keeping everything else the same, the wire gets the same voltage as before, but since the battery voltage EMF has decreased, it can still balance it out. Okay. What's another option? We can get rid of R as a whole. We can get rid of R. If we get rid of R or lower R, then according to potential divider, XY will get more voltage and this small part will be enough to balance this. So R was decreased or removed. That's an option. Or you could use a wire of greater resistance. If it was greater, then that would also work. So 4 things you could do to balance it at the position to the left of P. Decrease E2, increase E1, reduce R, or use wire of greater resistance. And vice versa for if you balance it at a point to the right of P. Great question. Nucleus P has 144 neutrons and 93 protons. Nucleus P is unstable and undergoes alpha decay. Okay, alpha decay. 144 plus 93. 237. Alpha decay. to form Q. So this turns into 91, this turns into 233. Then it undergoes beta minus decay to form R, electron antineutrino. So mass number remains the same, 233, but this increases by 1, 233 and 92. So I'm looking for 92, and the neutron number will be 233 minus 92, 233 minus 92, which is 141. Okay, so 92 and 141, what does that match with? 38 is A, perfect. 39. The diagram shows the quark composition of 4 different hadrons. One of the hadrons is a what's this called? I forgot the name of the symbol. The summation symbol, basically. Wait, let me just Google it. Summation symbol name. Sigma. It's basically sigma. Capital. It's the capital sigma. Small sigma is this. And this is the capital sigma summation. Okay. It's not summation essentially. Yeah, it's sigma. It has a charge of plus E. Where is the elementary charge? Which hadron could be this particle? So up is plus 2 by 3. Down is minus 1 by 3. Strange is also minus 1 by 3. So not A, because it's minus 1 by 3, minus 1 by 3, minus 1 by 3. That's minus 1. We are looking for plus 1. So not A. This is also minus 1 by 3, minus 1 by 3, minus 1 by 3, minus 1. Not B. This one up, plus 2 by 3, minus 1 by 3, minus 1 by 3. This is actually 0, not this. And this one, plus 2 by 3, plus 2 by 3, minus 1 by 3. 4 by 3, minus 1 by 3, which is in fact the correct answer, plus 1. Which type of particle is comprised of the most quarks? Lepton is a fundamental particle. Antiquark is also a fundamental particle. And baryon is made up of 3 quarks, while meson is made up of 2 quarks. Although both are part of the family of hadrons, baryons are made up of 3 quarks and mesons are composed of 1 quark and 1 antiquark. So 2 quarks, 3 quarks. So the answer is B. Okay guys, that has been it. 2 or 3 questions were a bit hard here and there, but overall easy variant. You could get A star easily. Hopefully I could break things down, and if you have any other queries, please do comment below and drop down requests down below. And I'm gonna drop the link for the registration form for my mocks and the crash course or revision batch starting from February 2025. And I'll be doing an iPhone giveaway at the end of this month if you're interested, for my subscribers only. So look out in the channel. And like the video if this helped you, helps with the algorithm, and subscribe to the channel. Quick shout out to my top tier patron for the month, Nigel. I have one-on-one video meetings with him. He supports me on Patreon. I'll drop a link for that down below as well if you need more help, personalized help and study tips. So I'm gonna link the paper for May-June 2024, paper 1-1 up here, and the paper for May-June 2024, paper 1-2 down here, and the playlist for physics paper 1 MCQ up here. And remember to hit the subscribe button. See you guys. Bye bye.